Problem Introduction. Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 6, Zigzag conversion. This is a classic dynamic programming problem, rated as medium difficulty, perfect for sharpening your coding interview skills. The problem statement asks us to convert a given string into a zigzag pattern with a specified number of rows, and then read the string out row by row. For example, if the input string is PayPalishiring and the number of rows is 3, the zigzag pattern would look like this. P A Y P A L S H I R I N G, and the output string we're aiming for would be PHNAPLSIGYR. The challenge lies in efficiently reconstructing this string. We'll explore different approaches, and I'll show you how to optimize your solution. Let's dive in. Understanding with examples. Let's solidify our understanding with a couple of examples. Imagine the string LeetCode sharing with 4 rows. Can you picture the zigzag pattern? Let's work it out together. The pattern would create something like this. LDR ECEI TISH Codeiashiring. And the final output would be LDROIHCIHRNG. Notice how the characters are written diagonally, then back up, and the pattern repeats. Now, let's try another one, ABCDFG with 2 rows. This would create ACEG BDF, resulting in a SEGDF. See how it changes with a different number of rows and a different string length? Understanding these patterns is crucial to crafting an effective algorithm. Let's move on to consider our solution approaches. Brute force approach. A brute force approach might involve iterating through the string and directly placing characters in their zigzag positions according to the row number. While conceptually straightforward, this approach could become incredibly inefficient, especially with very long strings. Imagine having to create the entire zigzag structure in memory and then extracting the string. This method will involve lots of nested loops and conditional checks, leading to a time complexity that might easily exceed O of n squared, making it unsuitable for large inputs. We need something much more elegant and efficient. Therefore, let's proceed to a much more optimal approach. Optimal solution. The optimal solution leverages a clever observation. Instead of building the zigzag structure, we can directly reconstruct the final string by carefully tracking the movement of the characters as they populate the rows. We can achieve this with a single pass using O, N, extra space. Think of it like this: we iterate through the string. We keep track of the current row. We add the current character to that row. Then, depending on whether we're moving down or up, we adjust the row number to create the zigzag pattern. The key is to efficiently handle the transitions between rows and avoid unnecessary computations. This strategy will vastly improve our efficiency compared to the brute force approach. Code implementation. Let's see the code in Python. We'll use the optimal strategy we just discussed. First, we initialize an array of strings, 1 for each row. Then, we iterate through the input string, keeping track of our current row and direction. We append the character to the correct string in the array. When we reach the top or bottom row, we reverse the direction. Finally, we concatenate all the strings in the array to produce the final zigzag string. It's quite concise and elegant. Let's see it in action. Show Python code and explain each line. Time and space complexity. Now, let's analyze the time and space complexity of our optimized solution. We iterate through the input string only once, therefore, the time complexity is linear, which is O of n, where n is the length of the string. In terms of space complexity, we use an array to store the characters for each row. The size of the array is proportional to the number of rows and the length of the string, but essentially, it remains linearly proportional to n, as well as the number of rows, which can be considered a constant relative to the string length. So, the space complexity is also O of n. This is a significant improvement over the brute force approach's much larger complexity. Engagement break. So, there you have it, a clear, efficient solution to the zigzag conversion problem. Before we wrap up, I'd love to hear your thoughts. Did you find this explanation helpful? What other LeetCode problems would you like me to cover? And don't forget to like this video, subscribe to the channel for more code